Why does a piano sound like a piano? We can play the same note on different instruments and the pitch will be the same, but the notes will sound unambiguously distinct. A pipe organ sounds like a pipe organ. A violin sounds like a violin. The sound of a person singing cannot be replicated by any musical instrument. And conversely, we can't sing in a way that will make us sound like a piano, no matter how hard we try. So what is it about the sound of two notes at the same pitch that makes each note sound unique? So first things first, sound arises from the back and forth oscillation of particles. The difference in pressure created by those oscillations are interpreted by our brains as sound. These pressure waves can be represented on a graph, with the amplitude of the pressure on the vertical axis and time on the horizontal axis. Now, most sound waves are made up of many different waves comprised of different frequencies, all combined together at any given moment. And it's hard to tell what those frequencies are just by looking at a raw waveform. There are lots of peaks and valleys, and it's all a bit messy. But we can convert these complex waveforms in a way that allows us to see their constituent frequencies. If we do that for this wave over here, we can see that it's actually made up of 4 unique waves, each with its own frequency. The first wave has a frequency of 1 Hz, meaning it oscillates once every second. The second wave has a frequency of 2 Hz. It oscillates twice a second. The third wave oscillates 3 times a second, and the fourth oscillates 4 times a second. The second, third, and fourth waves have frequencies which are integer multiples of the first. They're called harmonics of the first wave, which is called the fundamental frequency. Sound waves produced by musical instruments are comprised of a fundamental frequency and corresponding harmonics. Let's take a look at middle C on a piano. You can see 8 distinct peaks, a fundamental frequency at 261 Hz, and 7 other peaks, which are harmonics, integer multiples of the fundamental frequency at 261 Hz. So when you play middle C on a piano, you are hearing all of these sound waves combined together. Now let's look at middle C on an accordion and middle C on a clarinet. All 3 notes have a fundamental frequency at 261.63 Hz. That's the exact pitch frequency of middle C. And if we isolate the fundamental frequency for each of the 3 instruments, it turns out that they sound exactly the same. This is the fundamental frequency for the piano, and for the accordion, and for the clarinet. We can do the same thing for the 5th harmonic: piano, accordion, and clarinet. It sounds exactly the same for each instrument. So if the harmonics all sound the same, why do the notes sound different? If we look at the pattern of the harmonics for the piano, we see it's quite different than the pattern for the accordion. The accordion has many more harmonics at higher frequencies compared to the piano. And looking at the harmonics for the clarinet, we notice that the second harmonic is barely present at all. And that's the key to the distinctiveness of each instrument. The difference in the relative amplitudes of the harmonics is what gives rise to the distinct sound of each note. It's what makes the piano sound unmistakably like a piano, and a clarinet sound like a clarinet. Every instrument will produce harmonics in a unique way, and as a result, will produce a unique sound. Thanks for listening. I hope you learned something new, and as always, stay curious.